The universe is hiding something from us. We are about to journey through 25 of its greatest secrets, phenomena so baffling they defy everything scientists think they know. You will discover why entire galaxies are being pulled toward an unseen force, and what strange object passed through our solar system, leaving no explanation. This is a countdown of cosmic puzzles where the answers could rewrite physics itself. What you believe is waiting for us in the dark. Our cosmic inventory has a staggering error. Scientists have discovered that roughly half of the ordinary matter in the universe, the stuff that builds every star, planet, and person, has simply vanished. This is not the mysterious dark matter or dark energy, but the normal atoms, the baryonic matter that we are made of. Observations of the ancient universe, specifically the afterglow of the Big Bang, tell us precisely how much of this regular matter should exist today. Yet when we add up everything we can see, from glittering galaxies to vast clouds of gas, we are left with a deficit so large it points to a fundamental gap in our understanding of the cosmos. So where did it all go? The leading theory suggests this missing matter is not gathered in neat, visible structures, but is instead scattered across space in an immense spider web-like network of incredibly thin gas. Astronomers call this the warm-hot intergalactic medium, or WIM. These are filaments of matter so diffuse and so hot that they are nearly invisible to our telescopes, emitting little light for us to capture. Finding them is like trying to see a single, faint thread woven into the fabric of a darkened room. This is where new eyes on the cosmos come in. Missions like the European Space Agency's Euclid Space Telescope are designed to hunt for these elusive strands. By mapping the universe in unprecedented detail, Euclid and its counterparts hope to finally spot the shadowy glow of this missing material, solving one of modern astronomy's most profound accounting mysteries. What other invisible structures are woven between the stars, shaping the universe in ways we are only beginning to suspect? This missing matter is not the only invisible force commanding our motion through the cosmos. Our entire galaxy, the Milky Way, is caught in a relentless river of space pulled by an unseen power. We are racing toward a specific point in the void at an astonishing speed of over 14 million miles per hour. The source of this immense gravitational pull is known to astronomers as the Great Attractor. Imagine the universe as a vast, flowing river, and our galaxy is a leaf caught in its current, swept along toward a colossal, hidden waterfall. That waterfall is the Great Attractor, a gravitational anomaly of almost unimaginable scale. It does not work alone. It pulls not just our galaxy, but thousands of others in our local region of space, all flowing in the same direction. Yet for decades, its true face has remained a secret. It lies in a region of the sky astronomers call the Zone of Avoidance. This is the plane of our own Milky Way galaxy, a thick band of cosmic dust, gas, and countless stars. Peering through this zone is like trying to see a distant mountain range through a dense, blinding fog. Our own galactic backyard obscures the very thing we are trying to reach. What could possibly possess enough gravity to tug on thousands of galaxies? The leading theory suggests the Great Attractor is not a single, monstrous object, but an immense supercluster of galaxies, a gathering of cosmic islands so vast that its collective gravity creates this powerful current. Surveys that can peer through the dust in radio and X-ray wavelengths have begun to map this hidden realm, revealing a concentration of mass known as the Norma cluster. But here is the mystery that deepens the intrigue. Even this massive supercluster does not seem to have enough gravity to fully account for our tremendous speed. It appears the Great Attractor itself may be just one part of an even larger, more distant, and far more massive structure pulling us, a structure we have yet to fully comprehend. So we are left with a humbling thought. We are not just moving aimlessly through space. We are passengers on a journey to an unknown destination, drawn by a force whose true nature is still hidden behind the veil of our own galaxy. What other colossal structures lie beyond our sight, silently steering the fate of everything we know? But the Great Attractor is merely a symptom of a far deeper and more profound mystery. For every bit of matter we can see, there is 5 times more that we cannot. This invisible substance, known as dark matter, is the true gravitational master of the cosmos, making up roughly 27% of everything in the universe. We do not see it, we cannot touch it, and it does not interact with light in any way. So how can we be so sure it is even there? The evidence comes from its ghostly gravitational hand. Look at a spinning galaxy. The stars on its outer edges should orbit much more slowly than those near the center, just as Pluto takes far longer to circle the Sun than Mercury does. Yet when astronomers measure these galactic rotations, they find something astonishing. The outer stars whip around just as fast as the inner ones. The only explanation is that the entire galaxy is embedded within a massive, invisible sphere of matter, a dark matter halo whose immense gravity is the only thing holding the speeding stars in place. This same unseen force binds entire clusters of galaxies together, preventing them from flying apart. Without dark matter, our universe as we know it would simply not exist. So what is it made of? Scientists have proposed several candidates, each more elusive than the last. One leading idea is a class of particles called weakly interacting massive particles, or WIMP. These are theoretical heavy particles that barely interact with normal matter, passing through our planet, our homes, and even our bodies by the trillions every second without a trace. Another candidate is the action, an incredibly lightweight particle that could be flooding the cosmos. To catch these phantoms, physicists have built exquisitely sensitive experiments in the most quiet places on Earth and beyond. Deep inside abandoned mines and under mountains shielded from cosmic rays, detectors wait for the once-in-a-lifetime bump that would signal a dark matter particle colliding with an atom. In space, instruments on the International Space Station scan for the unique energy signatures that would be produced if dark matter particles annihilated each other. Yet after decades of searching, the detectors remain silent. We are surrounded by an ocean of something that shapes the fate of galaxies, yet it slips through our finest scientific nets without a single confirmed whisper. This is not just a missing puzzle piece, it is a fundamental question mark placed over 95% of the universe. What does it mean that the cosmos is built from a substance we cannot perceive, a silent partner whose rules we have yet to learn? If dark matter's ghostly gravity holds the cosmos together, an even more baffling force is actively tearing it apart. This is dark energy, a mysterious pressure that makes up about 68% of the universe. While dark matter pulls galaxies together with its immense gravitational grip, dark energy does the exact opposite. It is pushing the very fabric of space itself apart, causing the expansion of the universe to accelerate at a staggering rate. Think of the universe as a loaf of raisin bread baking in an oven. The raisins are galaxies. Dark matter ensures the raisins hold together in clusters, but dark energy is the yeast, making the entire loaf of dough expand faster and faster, forcing every raisin to rush away from every other. This discovery in the late 1990s was so shocking it upended a century of cosmological thought. 2 independent teams of astronomers were studying distant stellar explosions called Type 1, a supernova. These explosions are standard candles, meaning they always shine with the same intrinsic brightness. By measuring how dim they appeared from Earth, scientists could calculate their precise distance. They expected to find that the expansion of the universe was slowing down, pulled by the collective gravity of all matter. Instead, they found the supernovae were much fainter and therefore farther away than they should have been. The only possible explanation was that the expansion of space was not slowing at all, but speeding up. This revelation earned the team leaders the Nobel Prize in Physics in 2011, and it plunged science into one of its greatest crises. What could possibly be stronger than gravity on a cosmic scale? The leading hypothesis points to a concept from Einstein's own equations, something he called the cosmological constant. This suggests that dark energy is an inherent property of the vacuum of space itself. Empty space is not truly empty. It is a seething foam of virtual particles popping in and out of existence, and this quantum activity may generate a repulsive force. As the universe expands and more space comes into being, more of this repulsive energy appears, leading to an ever faster flight. Yet this elegant idea comes with a devastating problem. When physicists calculate how strong this vacuum energy should be based on quantum theory, the number they get is wrong by a factor of 1 followed by 120 zeros. It is arguably the worst theoretical prediction in the history of science. So we are left with a universe dominated by a force we cannot explain, a force that determines the ultimate fate of everything. If dark energy continues to accelerate the cosmos, it could lead to a cold, lonely end where distant galaxies vanish over a cosmic horizon, leaving any future observers with a sky devoid of anything but darkness. The true nature of this dominant component of reality remains one of physics' most profound and unsettling mysteries. While the forces of dark energy operate on scales of unimaginable vastness, a single, fleeting signal from the depths of space once offered a very different kind of mystery. On a quiet August evening in 1977, a radio telescope known as the Big Ear, operated by Ohio State University, was silently scanning the heavens. Its routine data printout would soon become one of the most famous documents in the history of astronomy. A volunteer named Jerry Amon was reviewing the data days later when his eyes fell upon a sequence of letters and numbers so extraordinary that he circled it in red pen and wrote a single, powerful word in the margin: "Wow." The signal was a narrowband radio burst, precisely the kind scientists predicted an intelligent civilization might produce. It was not random noise, but a clean, focused transmission at a frequency of 1420 MHz, a frequency that happens to be forbidden for earthly transmitters because it is a quiet channel reserved for listening to the universe. This wow signal lasted for 72 seconds, the exact duration it would take for a stationary source to pass through the telescope's fixed field of view, growing to peak intensity and then fading away perfectly. It was a perfect candidate for a message from the stars, and then it was gone. Despite decades of searching with more powerful telescopes, targeting the same patch of sky in the constellation Sagittarius, the signal never repeated. Not a single whisper has ever been heard again. Explanations have been proposed and scrutinized. Some suggested it was a reflection from a piece of human space debris or a secret military transmission. More recently, a theory pointed to a passing comet, but the comets in question were not in the right part of the sky at that time. Each potential answer has crumbled under investigation, leaving the wow signal in a category of its own. It stands as a solitary, brilliant flash, a one-word testament to a possibility that vanished before our eyes. Was it a cosmic greeting that we were simply too slow to answer, or something else entirely, a natural phenomenon we still do not understand? The printout with its famous red ink remains, a permanent question mark hanging in the air. That solitary wow signal, a fleeting question from the void, was just the beginning. The cosmos is now known to shout at us with bursts of energy so powerful and so brief they defy belief. These are fast radio bursts, or FRB. In the span of a single millisecond, less time than it takes to blink, one of these events can release more energy than our sun emits over 80 years. The sheer power is staggering, a cosmic scream that travels billions of light years only to vanish almost the instant it begins. The story of their discovery is a testament to patience and digital archaeology. In 2007, a young astronomer named Duncan Lorimer was sifting through archival data from a radio telescope in Australia, recorded 6 years earlier. Buried in the noise was a spike of radio waves so intense and so isolated that it stood out like a lighthouse on a dark, empty shore. It was a one-off event, a blast from a single point in the sky with no obvious cause. For years, this lone signal was a profound puzzle. Was it a fluke, some bizarre instrumental error, or was it real? Today, the mystery has only deepened. Advanced telescopes now detect these bursts regularly, sometimes several times an hour from all corners of the sky. We have learned they come in two distinct flavors, which only adds to the intrigue. Some are one-hit wonders, a single, catastrophic millisecond flash from a source that then goes permanently silent. Others, however, are repeaters. They pulse again and again from the same patch of space, like a cosmic heartbeat with an irregular and unpredictable rhythm. So what cosmic engine could possibly produce such violent, fleeting, and sometimes repeating explosions? The most promising suspect is a type of dead star known as a magnetar. Imagine the core of a massive star that has collapsed into a city-sized ball of unimaginably dense matter, spinning rapidly and possessing a magnetic field trillions of times stronger than any magnet on Earth. A starquake on the surface of such a monster, a sudden cracking of its crust, could theoretically unleash a focused blast of radio waves powerful enough to be seen across the universe. This fits the profile of the one-off bursts perfectly, a stellar death cry of immense proportions, but the repeating bursts are harder to explain. What natural process can fire off multiple blasts from the same object without destroying it? Some scientists theorize that a magnetar could be orbiting a companion star, with its immense gravity periodically triggering eruptions. Others look to even more exotic possibilities, like cosmic strings, hypothetical defects in the fabric of spacetime itself. And yes, in the absence of a clear natural explanation, the speculative door remains open to more extraordinary ideas. Could these be the signatures of advanced civilizations, perhaps powering interstellar light sails with focused energy beams so powerful they briefly outshine entire galaxies from our perspective? While this is the least likely answer, it highlights just how baffling these signals truly are. Each new detection is a fresh piece of a puzzle we are still assembling, a brief flash illuminating a small part of a map whose full shape we cannot yet see. We are left listening to the echoes of cosmic catastrophes, events of unimaginable violence that flicker and die in the blink of an eye, challenging us to understand the forces that drive them. While our instruments listen for cosmic shouts and whispers, another star has been caught blinking in a way that should be impossible. KIC 8462852, better known as Tabby Star, sits about 1,500 light-years away, and it behaves like no other sun we have ever seen. Most stars show tiny, regular dips in brightness when a planet passes in front of them, perhaps dimming by 1%. Tabby Star is different. Its light plummets in chaotic, dramatic events, sometimes fading by an astonishing 22% before slowly recovering. That is not the shadow of a planet. It is the equivalent of a swarm of objects large enough to block out nearly a quarter of its light. This cosmic oddity was not first spotted by a powerful institution, but by citizen scientists. Volunteers with the Planet Hunters project, sifting through public data from NASA's Kepler Space Telescope, saw the strange light curve and knew they had found something extraordinary. They flagged it for professional astronomers, who were soon just as baffled. The dimming was far too severe and far too irregular to be caused by any known planet. So what could possibly be orbiting this star? The hunt for an explanation began, and the theories are as strange as the data itself. One idea proposes a vast, chaotic swarm of comets, thousands of them, passing in front of the star in a tight formation. Another suggests a thick cloud of circumstellar dust, the leftover debris from a planetary collision that shattered a world into billions of fragments. But the most captivating and controversial hypothesis points to something entirely artificial. Could we be witnessing the construction of a Dyson sphere, a hypothetical megastructure built by an advanced civilization to capture the energy of its sun? While astronomers consider this the least likely scenario, it underscores how thoroughly this star defies natural explanation. Years of continued observation have only deepened the enigma. The star has shown long-term, gradual dimming over a century, in addition to its sudden, deep drops. The patterns remain stubbornly unpredictable, a celestial light show with no discernible rhythm or reason. Tabby Star stands as a permanent reminder that even the most familiar objects in the sky, the stars themselves, can harbor secrets that challenge the very limits of our imagination. What other strange behaviors are written in the light of distant suns, waiting for a curious eye to notice? The unpredictable dimming of a single star pales in comparison to the silence that blankets the entire galaxy. With billions of potentially habitable worlds in the Milky Way alone, the cosmos should be teeming with civilizations. Yet when we listen, we hear only a profound and unsettling quiet. This is the heart of the Fermi paradox, a simple question with devastating implications. Where is everybody? The puzzle got its name from a casual lunchtime conversation in the summer of 1950. Physicist Enrico Fermi was discussing the possibility of interstellar travel with colleagues when he suddenly blurted out that now famous question. His point was razor sharp. If intelligent life is common, then even at a slow pace of galactic expansion, a single civilization should have had more than enough time to colonize the entire Milky Way. The evidence of their existence should be everywhere, from ancient ruins on nearby moons to the buzz of their communications filling the radio spectrum. But we see nothing, we hear nothing. The universe appears barren and empty, so what is stopping them or us from making contact? One of the most sobering answers is known as the Great Filter. This theory suggests that the evolution of life from its genesis to a spacefaring civilization is not a smooth path, but an obstacle course with at least one nearly insurmountable barrier. This great filter could lie in our past. Perhaps the spontaneous origin of life itself is an astronomically rare fluke, a spark of chemistry so unlikely that we are truly alone in the vastness. Or the filter could be ahead of us, a wall that every advanced civilization hits and none survive. This could be an innate tendency towards self-annihilation, where the discovery of technologies like nuclear weapons or artificial intelligence inevitably leads to extinction. It could be an external threat we have not yet conceived, a cosmic catastrophe that sterilizes planets on a regular schedule. If the filter is behind us, humanity has won a cosmic lottery of incredible odds. If it lies ahead, our future may be far bleaker than we imagine. Other solutions are less grim but equally strange. The zoo hypothesis proposes that advanced alien societies are already aware of us, but have chosen to place our world in a kind of cosmic quarantine. They observe us from a distance, not out of malice, but perhaps as a policy of non-interference, allowing a young species like ours to develop naturally without their influence. Another possibility is that we are simply looking for the wrong things. Their technology or methods of communication might be so advanced that they are indistinguishable from the natural laws of physics to our primitive instruments. Or perhaps the timescales are just too vast. Civilizations rise and fall in the blink of a cosmic eye, and we are simply alone in our particular epoch. The silence we hear is not an empty one, it is filled with questions about our own destiny. Are we the first to gaze at the stars and wonder, or are we destined to be a brief, lonely flicker in the dark, a cautionary tale for anyone who might one day listen? Even the silence of deep space can whisper a secret. As our first robotic ambassadors, the Pioneer 10 and Pioneer 11 spacecraft, ventured beyond the planets, they carried with them a golden plaque for any civilization that might find them. But these pioneers were also carrying a hidden mystery, one encoded in the faint, persistent signal of their journey home. Scientists tracking their velocity noticed something deeply wrong. Both spacecraft were experiencing a tiny, constant, and entirely unexpected deceleration, a slight but unshakable pullback toward the sun. this was the Pioneer anomaly. The force was minuscule, barely 10 billion times weaker than the gravity we feel on Earth's surface, but over millions of miles, this tiny push added up. It was as if the spacecraft were driving with a ghostly foot on the brake. For decades, this anomaly haunted planetary scientists. They investigated every conceivable cause. Was it the gentle pressure of the solar wind, the drag from tiny dust particles, or even a slight leak of propellant from the spacecraft's own systems? Each possibility was meticulously modeled and then dismissed. The pull remained, a stubborn fact that refused to go away. The implications were profound. If this was not an engineering fluke, it could mean our understanding of gravity itself was incomplete at the very edges of the solar system. Perhaps Newton's laws needed a tweak in the deepest, darkest reaches of space. The mystery persisted for over 30 years, a testament to how the smallest, most precise measurements can uncover the biggest questions. The solution, when it finally came, was not in the laws of physics, but in the simple physics of heat. A team of researchers realized the answer was radiating from the spacecraft themselves. The Pioneers were powered by radioactive plutonium, and that material generated heat. The spacecraft were designed to radiate this heat away into space to prevent overheating. But they were not perfect spheres. They had scientific instruments and antennae. This meant heat was not radiating away evenly from all sides. A tiny bit more thermal radiation was pushing off the back of the spacecraft from the warm power system than from the front, where the large dish antenna pointed at Earth. This anisotropic or directionally uneven thermal radiation acted like a faint photon rocket, ever so gently slowing the probes down on their path to the stars. It was the cumulative nudge of countless infrared photons, each carrying a minuscule amount of momentum, that created the anomalous deceleration. Once this thermal recoil force was meticulously calculated and subtracted from the trajectory data, the vast majority of the strange pull vanished. The case was largely closed, yet some researchers point out that a tiny fraction of the anomaly might still linger unexplained. The story of the Pioneer probe serves as a powerful lesson. It shows how science grapples with the unknown, chasing down a ghost for decades, only to find the answer was emanating from the spacecraft all along. But it also reminds us that precision is everything, and that the universe often hides its truths in the most subtle of details. What other tiny discrepancies in our data today are hinting at tomorrow's revolutionary discoveries? Even the faint, cold glow of the universe's birth holds a strange and unsettling pattern. The cosmic microwave background radiation is the oldest light we can see, a snapshot of the infant cosmos just 380,000 years after the Big Bang. It should be the ultimate example of cosmic randomness, a nearly uniform sea of microwave light with tiny, gentle ripples that are the seeds of all future galaxies. These ripples should be scattered in every direction without any preferred alignment, a final confirmation that the universe is, on the largest scales, the same everywhere. Yet it is not. When scientists created a detailed map of this ancient light, they found the fluctuations were not random at all. They appear to be subtly aligned along a specific line, a mysterious corridor through space that cosmologists with a dark sense of humor have named the axis of evil. This is not a malevolent force, but a name that reflects how deeply it disturbs our fundamental models of the cosmos. The cosmological principle, a cornerstone of modern astronomy, states that the universe is homogeneous and isotropic. In simple terms, this means it should look roughly the same in every direction, with no special places and no central axis. The axis of evil directly challenges this idea. It suggests that the entire observable universe might have a preferred direction, a cosmic north that breaks the rules we thought were universal. How could the very fabric of the newborn cosmos show a preferred alignment? The debate over this axis is fierce and ongoing. Is it just a statistical fluke, a cosmic mirage created by our limited view? When you look at any random pattern long enough, your brain can start to see shapes that are not really there. Scientists have run countless simulations to see if a perfect, isotropic universe could by chance produce an alignment as striking as the one we see. The results are ambiguous, leaving room for doubt on both sides. Another possibility is that the effect is not in the cosmos, but in our own backyard. Perhaps our solar system's motion through the galaxy creates a subtle distortion in how we perceive the background radiation, a kind of Doppler lensing that imprints a false axis on the data. But when researchers correct for this motion, the alignment stubbornly persists. If it is real and not an illusion, the implications are staggering. It could be a fossil imprint from the very first instance of the Big Bang, a time when the laws of physics themselves were different. Perhaps the universe was born spinning, or its expansion was not perfectly uniform, leaving a permanent scar in the background radiation. Some even speculated could be a sign of a collision with another universe in the vast multiverse. The axis of evil remains one of cosmology's most profound and controversial puzzles. It is a whisper from the dawn of time, suggesting that our universe may not be as simple or as random as we believed, that its very foundations might be tilted in a way we are only just beginning to perceive. High above the swirling ochre clouds of Saturn, a geometric marvel defies the very nature of storms. Encircling the planet's north pole is a perfect, persistent hexagon, a cloud pattern so vast that each of its 6 sides is wider than our entire Earth. This is not a fleeting atmospheric whim, but a permanent fixture, a colossal structure of wind that has endured for decades and likely much longer. We first caught a fleeting, grainy glimpse of it in the 1980s when the Voyager spacecraft sped past, but it was the Cassini orbiter that revealed its true, breathtaking grandeur, confirming it was a stable, long-lasting feature of the Saturnian sky. Think of a hurricane on Earth, a chaotic spiral of immense power. Now imagine a hurricane with 6 razor-straight sides, spinning in a perfect honeycomb pattern for thousands of miles. This is the scale of the Saturn hexagon, so what cosmic machinery could possibly etch a polygon onto a planet? Scientists believe the answer lies in the physics of spinning fluids. Inside a rotating cylinder, if you spin the inner part faster than the outer wall, you can create stable waves, like the standing waves you see when you vibrate a plate of water. Laboratory experiments and sophisticated computer models suggest the hexagon is a giant, stable standing wave pattern, a ripple frozen in time within Saturn's raging north polar jet stream. The jet stream itself acts like a sheer boundary between different atmospheric bands, and under the right conditions, this shear can generate a pattern, with the hexagon being the most stable shape for Saturn's particular speed and density. Yet, while the lab models can create similar shapes, the perfect storm-scale stability of Saturn's hexagon remains just out of reach. Why a hexagon and not an octagon or a pentagon? Why has it remained so perfectly locked in place for so long, resisting the turbulence that should tear such a precise form apart? The precise mechanics that carve and maintain this astronomical artwork are still an active, beautiful mystery, a reminder that even the most familiar laws of physics can paint unexpected wonders in the skies of other worlds. From the geometric perfection of Saturn's clouds, we descend into a storm of a different kind, one that rages invisibly above our heads. Every second, our planet is bombarded by countless subatomic particles from deep space, most of them harmless protons or atomic nuclei. But a few are different. They are the ghosts of cosmic violence, arriving with so much energy that their power defies belief. These are ultra-high-energy cosmic rays, and they carry more punch in a single particle than a major league fastball. To put that in perspective, one of these tiny specks of matter can possess millions of times more energy than the protons we smash together in the world's most powerful particle accelerator, the Large Hadron Collider. They are the fastest, most energetic things we know of in the universe, and according to our best theories, they should not exist. there is a fundamental speed limit for these cosmic travelers, a point beyond which they should break down. This is known as the Greisen-Zatsepin-Kuzmin cutoff, or the GZK cutoff for short. The theory states that any particle traveling through space with energy above this limit will inevitably collide with the faint, cold photons of the cosmic microwave background, the afterglow of the Big Bang that fills all of space. When such a high-energy particle hits one of these ancient photons, it should create new particles, shedding its colossal energy in a cascade until it falls safely below the cutoff. Over the vast distances between galaxies, this process should act like a cosmic sieve, filtering out the most extreme particles long before they could ever reach Earth. Yet they do reach us. Our detectors have seen them. This means these cosmic rays cannot have traveled across the universe. They must come from somewhere relatively nearby in the cosmic scheme of things, within our own galactic neighborhood or a close cluster of galaxies. So what are the cosmic accelerators in our own backyard capable of such an unbelievable feat? The suspects are the most cataclysmic objects we know. One prime candidate is an active galactic nucleus, a supermassive black hole at the heart of a galaxy, devouring matter and spewing out jets of radiation and particles at nearly the speed of light. These jets could act as natural particle accelerators on a scale we can barely comprehend. Another possibility is a gamma-ray burst, the explosive death cry of a massive star, focusing its entire energy output into two narrow beams for a few fleeting seconds. The power in such a beam could easily launch particles to these impossible energies. But here is the core of the mystery. When we trace the paths of these ultra-high energy cosmic rays back into the sky, we find no obvious source. They do not point back to a brilliant quasar or the aftermath of a recent stellar explosion. The magnetic fields of intergalactic space bend their paths, scattering their trajectories like leaves in a hurricane, wiping out the address of their origin. They arrive as anonymous messages telling us of immense violence somewhere out there, but refusing to reveal the location of the crime scene. They are the ultimate cosmic detectives, carrying clues from the most powerful events in the universe, yet leaving us with the profound puzzle of where and what they truly are. Far beyond the orbit of Neptune, in the deep freeze of our solar system's outskirts, a cosmic crime scene awaits. This is the Kuiper Belt, a vast disk of icy remnants left over from the planetary construction phase billions of years ago. We expected this region to be a smoothly graded collection of debris, with smaller, more numerous objects becoming increasingly common the further out you go. But our telescopes have revealed something deeply wrong. Instead of a gentle slope, the population of these frozen worlds hits a wall. The number of objects does not gradually thin out, it plummets off a cliff. Beyond a certain distance, roughly 50 astronomical units from the Sun, the vast reservoir of ice and rock simply vanishes. It is as if a giant broom swept the outer solar system clean, leaving behind a stark and unexpected edge. This Kuiper Belt cliff is not just a curious feature, it is a direct challenge to the story we thought we knew about our own cosmic backyard. According to our best models of planetary formation, this abrupt drop-off should not exist. The primordial disk of dust and gas that swirled around our infant sun should have distributed this material more evenly, creating a gradually fading population of objects extending for hundreds of astronomical units. The cliff suggests that something dramatic happened in our solar system's youth, an event that fundamentally reshaped its outer frontier. So what could have carved this sharp boundary in the ice? One compelling theory points to the gravitational hand of a hidden architect, the same hypothetical world known as Planet 9 that is proposed to explain the strange clustered orbits of some distant objects could also be responsible for this cliff. A massive, undiscovered planet orbiting far beyond the Kuiper Belt would exert a powerful gravitational influence, clearing out a vast swath of space and shepherding the remaining objects into a sharp edge, much like Saturn's moons carve gaps in its rings. Another possibility reaches back to the Sun's earliest days, when it was born in a dense stellar nursery surrounded by thousands of other newborn stars. A close pass by a sibling star could have gravitationally plundered our outer solar system, stripping away the vast majority of the Kuiper Belt's primordial material and leaving only the truncated version we see today. Or perhaps the conditions in that initial protoplanetary disk were simply different than we assume, with a pressure drop or a change in composition creating a natural endpoint for planet formation. Each theory has its merits and its flaws, but all agree on one thing. Our solar system's history is missing a crucial chapter. The silent, empty space beyond the Kuiper Cliff is not just a void, it is a question. What other secrets about our origins are hiding in that darkness, waiting to be read in the faint reflected light of a distant ice world? The silent frontier of our solar system was suddenly breached by a visitor from another star. In October 2017, astronomers in Hawaii spotted a faint point of light moving at incredible speed. They named it Oumuamua, Hawaiian for scout, and it became the first interstellar object ever detected passing through our cosmic neighborhood. From the moment it was seen, it was clear this was no ordinary comet or asteroid. Its path was hyperbolic, meaning it was not bound by the sun's gravity and was just passing through on a one-way journey from the depths of interstellar space. As telescopes around the world swiveled to observe it, the strangeness only deepened. The object was tumbling chaotically, and measurements of its changing brightness revealed an astonishing shape. It was profoundly elongated, perhaps 10 times longer than it was wide, resembling a cosmic cigar or a flattened pancake tumbling through the void. Nothing like it exists in our own solar system. Then came the most baffling clue of all. As Oumuamua swung around the sun and began its journey back out into interstellar space, it did something it should not have. It sped up. This non-gravitational acceleration was slight but undeniable. Comets often exhibit this behavior when they are near the sun, as their ices heat up and vaporize, creating a jet of gas that acts like a weak rocket engine. This outgassing produces a visible cloud of dust and gas called a coma, a classic comet tail. Yet Oumuamua showed no coma whatsoever. Our most powerful telescopes scanned it intently and saw nothing, no hint of dust, no gas, no tail. It was a completely dark, dry, and inert object, yet it was accelerating as if pushed by an invisible hand. The scientific community scrambled for explanations. The leading theory today suggests that Oumuamua could have been a strange new class of object, a hydrogen iceberg. In the cold depths of interstellar space, a chunk of solid hydrogen could have formed. As it approached the sun, the theory goes, the hydrogen would have begun to sublimate, turning directly from a solid to a gas. This outgassing would have provided the thrust for the acceleration, and because molecular hydrogen is invisible to our telescopes, it would explain the complete lack of a visible coma. It is an elegant solution, but it requires a set of cosmic circumstances that are purely theoretical and have never been observed. This gap in our understanding opened the door for a more extraordinary hypothesis. Harvard astronomer Avi Loeb proposed that Oumuamua's strange properties, its unusual shape, its lack of a tail, and its precise non-gravitational acceleration were all consistent with it being an artificial object, a piece of advanced alien technology. Specifically, he suggested it could be a light sail, a vast, thin sheet designed to be pushed by the radiation pressure from stars, much like a boat sail is pushed by the wind. A damaged or discarded light sail tumbling through space would fit the bizarre observational data. The scientific mainstream remains deeply skeptical of this idea, but it underscores a profound point. Oumuamua defied every easy classification. It was a real, physical object that we watched for 11 weeks, and its most fundamental nature slipped through our fingers. Now it is already too far away, receding into the darkness between stars, too faint for any telescope to ever study again. it remains a permanent enigma, a silent scout that delivered a message we are still struggling to decode. What other strange travelers are drifting between the stars, and will we be ready to understand the next one? Oumuamua's stark and alien geometry is not entirely alone in the cosmos. Far away in the constellation Monoceros, a dying star has painted a masterpiece of impossible precision. The red rectangle nebula glows with a deep crimson light, but its true wonder is its shape. While most nebulae are chaotic clouds or gentle spheres, this one forms a series of near-perfect concentric rectangles, like a cosmic ladder or a set of spectral boxes stacked one inside the other. It is a structure so sharp and geometric it looks deliberately crafted, a piece of celestial architecture that defies the usual messy rules of stellar death. At its heart lies a binary star system, two suns locked in a tight gravitational dance. This pair is responsible for the nebula's creation. As one of the stars reached the end of its life and began to shed its outer layers, the gravitational tug of war between the two stars sculpted that ejected gas and dust into two opposing cones. From our vantage point, we are looking directly down the barrel of these cones, their edges creating the vivid X shape and the illusion of a rectangle. The stunning ladder rungs, those evenly spaced lines across the structure, are thought to be evidence of a stellar heartbeat. Every few hundred years, the central binary system may undergo a periodic eruption, ejecting a new shell of material. As these expanding shells pile up over time, they create the nebula's layered appearance, much like the rings of a tree trunk record its years. Yet, this elegant explanation only deepens the mystery. The physical processes that can create such perfectly symmetrical and sharply defined ejections are not fully understood. The forces at play in that binary dance must be exquisitely balanced to produce not a ragged cloud, but a work of art with such straight lines and clean angles. It is a fleeting phenomenon, a protoplanetary nebula that will itself soon evolve, its gas dissipating into the void within a few thousand years. We are witnessing a brief, brilliant performance in a cosmic ballet, a dance of gravity and light whose precise choreography we are only beginning to learn. What other transient wonders are blooming and fading in the darkness, their perfect forms hidden by distance and time? Even the familiar face of the moon holds secrets that flicker in the corner of our vision. For centuries, astronomers gazing through their telescopes have documented strange, fleeting events on the lunar surface, brief flashes of light, unexplained glows, and patches of landscape that momentarily dim or blur. These are transient lunar phenomena, or TLP, and they remain one of the oldest and most elusive puzzles in astronomy. The famed astronomer Sir William Herschel in the 1780s reported seeing glowing red spots on the moon, which he believed could be evidence of volcanic activity. In the 1960s, multiple observers at different locations witnessed a bright, star-like flash within the large crater Alphonsus, an event that lasted for several minutes. These are not just ancient tales. Modern amateur and professional astronomers continue to log these transient events, though they are rare and notoriously difficult to capture and verify. So what is causing these ghostly lights and shadings on our seemingly inert neighbor? The moon is a world without an atmosphere, without weather, a place where change is measured in billions of years of impact craters. Yet something is happening there. Scientists have a menu of potential culprits, but no single one fits all the cases. One strong candidate is outgassing. The moon's interior may still hold traces of radioactive elements, and as they decay, they heat the surrounding rock, potentially releasing trapped gases like radon. When these gases vent to the surface, they could kick up fine dust that scatters sunlight, creating a temporary, hazy glow or obscuration. Another possibility lies in the moon's strange electrical environment. The lunar surface is constantly bombarded by the solar wind and ultraviolet light from the sun, which can build up static electricity in the dry lunar soil. This electrostatic charge could suddenly discharge like a miniature lightning bolt without thunder, creating a tiny, brilliant flash of light. Then there are the constant peppering of meteoroids. A small space rock striking the moon at tens of thousands of miles per hour would instantly vaporize, creating a brief but intense flash of heat and light visible from Earth. Finally, the solar wind itself, a stream of charged particles from the sun, could interact with the magnetic anomalies in certain lunar rocks, causing them to glow faintly. The problem is that each of these explanations works for some events but fails for others. A gas release might explain a slow, spreading glow, but not a pinpoint flash. A meteor impact flash would be instantaneous, not a minutes-long glow. The true frustration with TLPs is their unpredictability. By the time a large telescope can be slewed to the right coordinates, the event is almost always over, leaving behind no physical evidence. It is like trying to study a specific lightning strike after the storm has passed, with only a handful of eyewitness accounts to go on. This is more than just a scientific curiosity, it is a matter of practical safety. If we are to establish a long-term human presence on the moon, we need to understand its environment completely. Is the surface periodically venting hazardous gases? Are there regions prone to intense electrostatic discharges that could damage sensitive electronics? Unraveling the mystery of TLPs is directly linked to assessing the stability and safety of the lunar landscape for future explorers. The next wave of robotic and crewed missions will likely carry automated, wide-field cameras designed to monitor the moon's surface continuously, finally giving us the data needed to catch these lunar phantoms in the act. What will we learn when we finally see what has been hiding in plain sight on the world closest to our own? Deep within the heart of our own galaxy, a different kind of energy mystery is unfolding. The center of the Milky Way should be a chaotic but predictable place, filled with the gamma-ray glow of known objects like spinning neutron stars and the remnants of ancient supernova. Yet when scientists first mapped this region with NASA's Fermi Gamma-Ray Space Telescope, they found something more, a diffuse, spherical excess of gamma-ray radiation that envelops the galactic core like a ghostly halo. This is the galactic center excess, and it is a signal that simply should not be there in such abundance. Think of listening to a symphony and hearing the expected roar of the brass and the strings, but then detecting a persistent, unchanging hum underlying it all, a note that does not belong to any instrument in the orchestra. That is what astronomers are hearing in the language of gamma rays. So where is this mysterious energy coming from? There are two compelling and dramatically different explanations on the table. The first is a celestial population that has simply remained hidden from our view. Thousands of incredibly dense, rapidly spinning stellar corpses known as millisecond pulsars could be packed into the galactic center. Each one would be too faint for our telescopes to pick out individually, but their combined gamma-ray glow could perfectly mimic the smooth, spherical excess we observe. It would be like looking at a city from a great distance and seeing its general light, but being unable to pick out the individual streetlights and windows that create it. The second possibility is far more profound. This glow could be the first indirect glimpse of dark matter itself. The theory goes that dark matter particles, drawn together by immense gravity at the galaxy's core, could be colliding and annihilating each other. When a particle of matter meets its antimatter counterpart, they destroy each other in a flash of energy. If dark matter particles are their own antimatter, then these annihilations would produce a spray of gamma rays, creating the exact kind of spherical halo we see. This would be the long-awaited evidence for what dark matter actually is. Distinguishing between these two ideas is a monumental challenge that pushes our technology to its absolute limit. Is the glow truly smooth, as the dark matter hypothesis predicts, or is it actually grainy, composed of countless faint points of light from those unseen pulsars? The answer lies in finding just one of those points, scientists are now engaged in a painstaking cosmic hunt, sifting through the noisy gamma-ray data pixel by pixel, searching for a single, faint pulsar that would prove the stellar explanation. But the galactic center is a crowded and turbulent place, and picking out one faint, blinking star from that energetic fog is like trying to spot a single, distant lighthouse through a thick, stormy haze. The true source of this galactic heart of darkness remains one of the most tantalizing puzzles in modern astronomy. Is it a teeming city of dead stars, or is it the final, fading signature of the universe's most elusive substance, a signal from the silent partner that built our cosmos? That galactic core hums with an unresolved energy, but if we pull our view back to the very largest scales of the cosmos, we find a different kind of mystery, a profound and unsettling emptiness. In the constellation of Boötes, there lies a sphere of nothingness so vast it defies comprehension. This is the Boötes Void, a region of space roughly 330 million light-years across that contains almost nothing at all. To grasp that scale, imagine a bubble so large that if our own Milky Way galaxy were placed at its center, the next nearest galaxy would be tens of millions of light-years away in every direction. It is a cosmic desert of staggering proportions. Our universe, on its grandest scales, is supposed to resemble a sponge or a web, with vast filaments of galaxies surrounding empty bubbles, but the statistics of this structure have rules. A void this enormous simply should not exist. It is an anomaly so extreme it challenges our most fundamental models of how the cosmos organized itself after the Big Bang. The void was discovered in the 1980s by astronomer Robert Kirshner and his colleagues, who were conducting a large survey of galaxy redshifts. As they mapped the positions of thousands of galaxies, they found this gigantic, dark gap in the cosmos, a place where their telescopes found only a handful of galaxies where there should have been thousands. How could such a colossal emptiness form? One theory suggests it is not a single void, but the result of several smaller voids merging together over billions of years, like soap bubbles coalescing into one gigantic cavity. Another, more speculative idea is that the Boötes Void is not entirely empty. It might be filled with an immense concentration of dark matter, whose gravity is so weak it failed to pull in the normal, visible matter needed to form galaxies. This dark matter halo would be invisible to us, making the region appear barren while actually being dominated by the universe's most mysterious substance. There is even a fringe hypothesis that such a void could be the imprint of an encounter with another universe in the multiverse, a cosmic bruise left from a collision in realities beyond our own. Whatever its origin, the Boötes Void stands as a monument to our ignorance. It is a silent, sprawling reminder that the architecture of the universe on its grandest scales still holds surprises that can upend our understanding, that within the great cosmic web there are holes large enough to lose entire swaths of reality. What other immense structures or absences of structure lie waiting in the darkness, challenging the very maps we have drawn of existence? That faint pyramid of light you sometimes see after sunset is not a trick of the eyes. It is the zodiacal light, a soft, ethereal glow stretching upward from the horizon along the same path the sun and planets travel. For centuries, its explanation seemed settled science. This luminous cone is sunlight, scattered by countless microscopic dust particles that form a vast, lens-shaped cloud enveloping the inner solar system. These tiny grains, the leftover debris from asteroid collisions and crumbling comets, float in the void, and when the sun is just below the horizon, its light illuminates them from behind, creating this celestial pillar. It is a beautiful and seemingly straightforward phenomenon, a gentle reminder of the dusty construction site our solar system remains, but recent data has thrown this tidy story into disarray. As NASA Juno spacecraft sped toward Jupiter, its sensitive star tracking cameras were mapping the sky for navigation. They began picking up impacts from this very interplanetary dust, but the pattern of these hits told a shocking story. The dust cloud was not uniform, and its origin point seemed to lead scientists to a surprising culprit: Mars. The data suggests that the red planet itself may be shedding immense quantities of dust into space, potentially from its violent dust storms that can engulf the entire planet. How could Mars be contributing so significantly to a solar system-wide dust cloud? The existing models cannot fully account for it. The thin Martian atmosphere should not be able to launch enough material into escape velocity to explain the Juno observations. This implies there is a mechanism at work on Mars or in its vicinity that we do not yet understand, a process that is steadily feeding the zodiacal cloud with a previously unknown stream of material. It is a humbling revelation. Even a phenomenon we have observed for generations, one we thought was fully explained, can conceal a fundamental mystery. The gentle light in the twilight sky is now a clue pointing to an active, dusty process happening right next door, a reminder that the story of our own cosmic backyard is still being written, one speck of dust at a time. The gentle dust of our own solar system is a familiar mystery, but the true enigma governing cosmic motion lies far beyond. A spiral galaxy is a majestic pinwheel of stars, and for generations we believed we understood its clockwork. According to the laws of gravity as defined by Newton and refined by Einstein, the speed of a star's orbit should be dictated by the mass lying inside its path. Picture our own solar system, where Mercury races around the Sun while distant, icy Pluto crawls along its lonely circuit. We expected galaxies to behave the same way, with stars near the bright, crowded core whipping around at tremendous speeds, while those far out in the sparse galactic hinterlands should be drifting along at a comparative crawl. But when astronomers began to carefully measure the orbital velocities of stars across spiral galaxies, they found something that shattered this elegant expectation. The data revealed a flat rotation curve. Whether a star was close to the luminous center or far out in the faint, sparse edges, it was moving at roughly the same incredible speed. This was not just a small discrepancy, it was a fundamental violation of the rules of gravity as we knew them. The visible mass of stars, gas, and dust simply could not provide enough gravitational glue to hold these speeding outer stars in their path. The only possible explanation was that the entire luminous galaxy we see is embedded within a colossal, invisible sphere of matter, a massive halo whose gravity dominates the outer regions. This dark matter halo provides the extra gravitational pull, yanking on those distant stars and forcing them to orbit just as fast as their inner cousins. It is the ghost in the machine, an unseen hand that steers the very motion of galaxies. This rotation curve problem, first solidly documented by astronomer Vera Rubin in the 1970s, remains one of the most direct and undeniable pieces of evidence that we are missing the vast majority of the universe's substance. What does it mean that the beautiful spiral arms we see are merely decorative tracers, swirling within an ocean of something we cannot see, a hidden architecture that holds the entire cosmic structure together? For decades, we have actively broken that silence with our own calls into the void. The search for extraterrestrial intelligence, or SETI, has spent over half a century methodically scanning the cosmos, aiming powerful radio telescopes at thousands of stars, listening for a whisper of pattern, a signal that screams of artificial design. We have combed through the cosmic static, searching for a beacon, a stray transmission, anything that would say, "You are not alone." The result of this grand, multi-generational experiment is a profound and unsettling quiet. Not a single confirmed whisper has ever been found. This is not just an absence of data, it is a positive result of silence. The Great Silence is a real, measurable phenomenon that grows louder with every empty scan. So where is everybody? The chilling possibility of the Great Filter becomes unavoidable. This is the idea that there is at least one nearly insurmountable barrier on the path from non-life to a spacefaring civilization. If this filter lies in our past, then we are the winners of a cosmic lottery of unimaginable odds. Perhaps the spontaneous genesis of life itself, that first miraculous spark in the primordial soup, is so astronomically rare that we are the first and only to have achieved it in our galaxy. This would make our existence and our consciousness a truly singular and precious accident in a vast, sterile universe. The alternative is far more grim. Perhaps the filter is still ahead of us. Maybe every advanced civilization, upon reaching a certain technological threshold, inevitably discovers the means of its own destruction. This could be nuclear war, a climate catastrophe of their own making, or a technology like artificial intelligence that turns against its creators. The silence, then, would be a graveyard quiet, the final testament to countless civilizations that rose, flourished, and then snuffed themselves out. We would be listening to the echoes of our own potential future, but there are other, less terrifying possibilities. Perhaps we are simply looking for the wrong things. An intelligence a million years more advanced than ours might not use clunky radio waves for communication. They might use neutrino beams, gravitational wave modulations, or something we have not yet discovered, a physics so advanced it is indistinguishable from magic to us. Their conversations could be flowing all around us, embedded in the fabric of spacetime, and we lack the ears to hear them. Or they may have transcended biological existence entirely, uploading their consciousness into vast, silent computational networks or merging into a single planetary mind that no longer feels the need to broadcast into the void. The Great Silence forces a humbling introspection. It asks us to consider that intelligence might not be a common endpoint of evolution, but a bizarre fluke. Or that when it does arise, its nature and its goals are so fundamentally alien to our own that we would not even recognize its signature if we saw it. The empty skies are not a void, they are a mirror, reflecting back our deepest questions about our own place in the cosmos and the ultimate fate of all who dare to reach for the stars. That profound silence echoes a different kind of quiet problem, one etched into the very first atoms of existence. Our universe began in a forge of unimaginable heat, a process called Big Bang nucleosynthesis that forged the first light elements in mere minutes. The calculations for this cosmic recipe are spectacularly precise, telling us exactly how much hydrogen and helium should have been created. And when we look out at the oldest stars and the most pristine clouds of gas, the amounts of hydrogen and helium we see match those predictions with breathtaking accuracy. It is a stunning confirmation of our origin story, but one ingredient is stubbornly wrong. The theory predicts that a specific, small amount of the metal lithium should also have been forged in that primordial fire. Yet when we measure the lithium content in the ancient stars of our galaxy, the oldest relics we can find, the amount is only about 1/3 of what it should be. A significant portion of the universe's original lithium has simply gone missing. This is the lithium problem, a small but glaring crack in the otherwise flawless foundation of the Big Bang theory. How could the calculations be so perfect for two elements and so wrong for a third? Scientists have proposed several fascinating solutions, each probing the edges of our understanding. One possibility takes us inside the ancient stars themselves. Perhaps these stellar seniors are not pristine containers after all, but sophisticated chemical factories. Their internal processes might have slowly destroyed that primordial lithium over billions of years, burning it up in nuclear reactions and thus hiding the true initial amount from our telescopes. Another idea is that our measurements are incomplete. Maybe the lithium is not missing, but simply hiding in regions we have not yet observed, perhaps locked away in the atmospheres of stars that are slightly cooler or hotter than the ones we have studied. The most dramatic solution, however, points to new physics. The conditions of the early universe might have been subtly different than we assume. The presence of exotic, unknown particles in that first fiery moment could have altered the nuclear reaction rates, suppressing the production of lithium just enough to solve the discrepancy. This tiny anomaly, this one mismatched number in the cosmic ledger, could be our first clue to a particle or a force that operated only in the universe's first fleeting seconds. It is a quiet reminder that even our most successful theories might still be missing a few lines of code, a small bug in the program of creation that has yet to be patched. The serene perfection of Hoag's object is a lie. Floating in the constellation Serpens, this galaxy presents itself as a cosmic bullseye, a nearly flawless ring of brilliant blue stars encircling a core of ancient yellow suns. A dark, seemingly empty gap separates the two, creating a structure of such geometric purity it looks more like a work of art than a natural astronomical phenomenon. Most ring galaxies, like the famous cartwheel, are the result of a violent bullseye collision, where a smaller galaxy punches through the center of a larger disk galaxy. The gravitational shockwave sends a ripple of star formation rushing outward like a stone dropped in a pond, leaving a temporary ring of young, blue stars in its wake. But Hoag's object stands alone. There is no second galaxy nearby, no culprit fleeing the scene of the crime, and no central bar or spiral arms that would hint at a recent disruption. It is a perfectly isolated mystery. How can such a perfect ring exist without a visible cause? One theory suggests we are witnessing the aftermath of an immensely ancient collision, so old that the galaxy that caused it has long since merged completely or drifted away into the intergalactic void, leaving no trace for our telescopes to find. Another, more radical idea is that Hoag's object represents a rare and stable configuration of a galaxy, one that formed through a different, more gentle process entirely. Perhaps instabilities in a primordial cloud of gas caused it to naturally settle into this perfect ring and core structure. Yet, the physics that would allow for such a serene birth remain elusive. Its beautiful, balanced appearance is a cosmic facade, masking a history of either unimaginable violence or a formation process we have yet to discover. What other serene wonders in the sky are hiding turbulent secrets just beyond our understanding? This fundamental disagreement over the universe's expansion rate is tearing at the seams of modern cosmology. We call it the Hubble tension, and it is a crisis born from precision. The Hubble constant, a number representing how fast the cosmos is expanding today, should be a single, universal value. Yet our best tools for measuring it are delivering two different, stubbornly inconsistent answers. One method looks back to the very beginning, to the cosmic microwave background. By studying the subtle patterns in this ancient afterglow, physicists can calculate how fast the universe should be expanding now. It is like determining the top speed of a car by examining the blueprint of its engine. The other method uses the nearby universe as a cosmic speedometer. Astronomers observe pulsating stars called Cepheid variables, whose predictable brightness allows for accurate distance measurements, and then watch how fast those stars and the galaxies they reside in are rushing away from us. This is like clocking the car's speed with a radar gun. The problem is, the radar gun measurement is consistently faster than the blueprint prediction. The numbers do not match, and the gap is far larger than any possible margin of error. This is not a small statistical fluke, it is a 5-alarm fire for our understanding of physics. So what could be causing this rift in reality? One thrilling possibility is that we are seeing the fingerprints of unknown physics at work in the early universe. Perhaps dark energy, the force driving cosmic acceleration, is not constant as we have assumed. Maybe it has been strengthening over time, or it interacts with dark matter in ways we have not yet imagined. This would mean our standard model of cosmology, the lambda-CDM model, is incomplete, missing a crucial ingredient that alters the expansion history. Another, more sobering possibility is that one of our measurement techniques contains a hidden, systematic error. Perhaps our understanding of Cepheid stars is subtly wrong, or our maps of the cosmic microwave background have an unaccounted for distortion. Scientists are now in a race to find out, Next-generation observatories like the James Webb Space Telescope and the Nancy Grace Roman Space Telescope are being tasked with cross-checking these measurements with unprecedented accuracy. They will peer at Cepheid stars with sharper eyes and map the cosmos in finer detail, hoping to find the source of the discrepancy. The Hubble tension is more than a scientific disagreement, it is a cosmic crossroads. Its resolution will either expose a flaw in our most cherished theories or unveil a new chapter in physics, revealing that the universe's expansion is governed by rules we have only just begun to suspect. Even the ultimate symbols of cosmic destruction, black holes, are not the final word. They too are hiding a secret that strikes at the very heart of reality. When Stephen Hawking first applied the strange rules of quantum mechanics to these gravitational monsters, he made a startling prediction: black holes are not entirely black. Due to quantum fluctuations at the very edge of their event horizons, they should slowly leak energy, radiating it away into space over unimaginable eons. This Hawking radiation is an incredibly slow process, but it means that even black holes have a finite lifespan and will eventually evaporate, vanishing from the cosmos in a final, faint puff of energy. This discovery was brilliant, but it created a paradox so deep it has divided physicists for decades. The problem lies with information. Imagine you have a book, a unique object filled with specific information, the story of your life. You throw it into a black hole. According to Einstein's general relativity, the book is gone forever, its information crushed into the singularity, never to be seen again. The Hawking radiation that the black hole emits as it evaporates is purely thermal. It is random noise like the static from a detuned radio. It carries no fingerprint, no hidden code about the book that fell in. When the black hole is finally gone, the information about your book has seemingly been erased from the universe, and that is the catastrophe. The core principle of quantum mechanics is that information can never be truly destroyed. It can be scrambled, it can be hidden, but it must be preserved in some form. If you could destroy information, you could violate causality, and the entire logical framework of quantum theory would collapse. So we are left with a fundamental contradiction. Does the information get destroyed, breaking quantum mechanics, or is it somehow preserved, forcing us to rewrite our understanding of black holes and gravity? The search for a solution has led to some of the most mind-bending ideas in modern physics. One leading proposal is the holographic principle, which suggests that all the information about what falls into a black hole is not lost inside, but is instead encoded on a two-dimensional surface at its event horizon, like a cosmic hologram. The three-dimensional interior is an illusion, and the information is slowly released in the Hawking radiation, albeit in a form so scrambled we could never decode it. Another radical idea is the firewall hypothesis. It proposes that instead of a smooth passage across the event horizon, there is a literal wall of blazing high-energy particles that would instantly incinerate anything falling in. This firewall would preserve information by preventing anything from actually entering the black hole in the first place, but it violates the principle of equivalence, a cornerstone of general relativity. Resolving this paradox is not just an intellectual exercise, it is the essential key to unlocking a theory of quantum gravity, a single set of laws that can describe the universe from the smallest particle to the largest cosmic horizon. The fate of a single book falling into a black hole holds the secret to the most fundamental rules of existence, a final puzzle waiting in the darkness for a generation of thinkers yet to come. These 25 cosmic riddles form a map of our ignorance, charting everything from the silent pull of dark matter to the evaporating paradoxes of black holes. But this is not a map of failure. Each of these mysteries, from the faint lithium deficit to the vast Boötes void, is a frontier. They are the glowing edges of the known, the places where our current understanding ends and the next great discovery begins. They remind us that science is not a dusty collection of answers, but a living, breathing quest for questions. This journey does not end here, it is an open invitation. The solutions to these puzzles will be written by the next generation of curious minds, by the stargazers and the codebreakers, and perhaps even by someone watching this now. The universe is not a locked room, it is a conversation, and we are only just learning how to listen. So the next time you find yourself under a clear night sky, look up. Let your eyes trace the band of the Milky Way and remember the great attractor pulling us silently through the void. Think of the silent, waiting telescopes and the patient scientists grappling with data that defies explanation. Wonder is the first step toward discovery. Tell us in the comments which of these mysteries captured your imagination the most, and subscribe to continue this journey with us to the very edge of human knowledge. The cosmos is waiting.